Okay, so I want to talk a little bit about HVAC, superheat, subcooling. What is it? What is superheat? Well, superheat is the heat that's absorbed above the refrigerant's saturation temperature. Now, maybe you probably heard this before, but what does it mean? The saturation temperature. The saturation temperature is the point at which the refrigerant boils. In other words, changes state from liquid to vapor or from vapor to liquid. Think about water. Water is liquid. You pour water in a pot, it's just liquid water. You raise the temperature of that water to 212 degrees atmospheric pressure. That's just basically, we know that water boils at 212 degrees. So just keep it simple, 212 degrees atmospheric pressure. Well, it's liquid all the way up until it reaches 212 degrees, at which point it begins to boil. That point is the saturation point. That point is the saturation temperature. That point is the point at which the refrigerant or water, in this case, there is liquid and vapor present. When there's liquid and vapor present, that's the saturation temperature. So why is the saturation temperature important? Well, it's important because that's the point at which the mass amount of heat is being absorbed or rejected. You have to 1 ton of cooling is equivalent to 12,000 BTUs per hour. Okay, now understand, a BTU is how we measure heat energy. So 12,000 BTUs per hour have to be moved on a 1 ton unit. And this is the type of heat energy that's being moved during saturation. So back to the water example, 1 pound of water, the temperature chain is increased by 1 degree using 1 BTU. Remember, BTU is heat energy. So 1 BTU can change the temperature of 1 pound of water 1 degree. That goes all the way from 33 degrees, because we know water freezes at 32, so that's different. So 33 all the way up to 211 degrees. Each degree takes 1 BTU. Well, when the liquid water reaches the saturation temperature, the temperature at which it begins to boil, which is 212 degrees, it now takes 970 BTUs of heat energy to change the state of that water from 212 degrees liquid to 212 degrees vapor. It's still 212 degrees, and